given this question, if z is equal to 3 positive 2i, show that z, iz and z positive iz represent an isosceles triangle. Now, for an isosceles triangle, we should know that two of its sides are equal, right? Two sides are equal. So this is the property of an isosceles triangle. So we start off by assigning the complex numbers to the vertices. So this is how we are going to do. Let A, B, C be an isosceles triangle, and let the vertices, let z, iz, z positive iz represent the vertices of triangle ABC. Now z is given to be as 3 positive 2i. So let us represent these points. Now if I were to take this as 1, 2 and 3, so 3 is here and this is 1 and 2. By the way, this is the real axis, this is the imaginary axis. So 3 and 2, so this would be the point. Okay, so from the origin, so we need to represent it by a position vector. Okay, so this point will be A, right? Now next is, because we are going to be taking the points according to the order in which the representation is given. So next is given to be as I times z. So I times z means I of 3 positive 2i. So that is going to be 3i minus, in fact it's going to be positive 2i squared, but I squared is negative 1. So that's going to be 3i negative 2, which is going to be negative 2 positive 3i. Okay, so we need to represent that point. So negative 2 positive 3i, where would that point be? If this is negative 1, this is negative 2, so negative 2 is going to be here, positive 3i. So this is going to be positive 1, positive 2 and positive 3. So that point is going to be over here. Okay, now I can mention this point as, say, some point as C. So let us make the connection. So this is my vertex C. Okay, now we got the final point. The final point is given to be as z positive iz. So z is 3 positive 2i, and iz, we know that iz is going to be negative 2 positive 3i. So that's going to be 3 positive 2i, negative 2 and positive 3i. So that's going to be, I can add these two and I can add these two, is going to be 1 positive 5i. So 1 is here, this is 4 and this is 5, so that point is going to be over there. So if I were to connect these points, right, so this is the triangle we have got. So A is z, B is z positive iz, and C is iz. So this is what we have got. Now this is very important. This Argand diagram is very important. Okay, and now we are going to find what happens if we have to evaluate the distance AC or AB or BA. So let's start by finding, okay, let us find AB. So what is AB? So to find AB, I need to know what is AB squared. Now AB squared is going to be the modulus of, we start from the end of B, so it's going to be Z positive IZ negative Z, and that has to be squared. Simply using this formula, modulus of Z positive IZ negative Z raised to the power 2. So that's going to be modulus of, now the positive Z negative Z gets cancelled, giving me IZ with the inside the modulus raised to the power 2. Now IZ has been found to be as 3I negative 2 modulus raised to the power 2. So you're taking the modulus of this quantity, so that's going to be root of 3 squared positive 2 squared, and that has to be squared. Okay, so this is going to be root of 3 squared is 9 positive 2 squared is 4, which has to be squared here. So it's going to be root of 13. So when you square it, it's the square root and the square gets cancelled, giving you 13. So next we need to find what is BC squared. So BC squared, we start with C, so that's going to be IZ negative of the coordinates for Z, B is going to be Z positive IZ, and that has to be raised to the power 2. So this is the formula. Use this formula. Just by using this formula, you will be able to obtain the solution. Now IZ positive, negative IZ, they get cancelled, giving you negative Z. So you have a negative Z there, and that has to be raised to the power 2. So this is going to be, now Z is given to be as 3 positive 2I. So that is going to be, of course the square is there, that's going to be negative 3 negative 2I raised to the power 2. So when you take the modulus of this is going to be root of negative 3 squared is 9 positive 2 squared is 4, and that has to be raised to the power 2. So this is going to be root of 13, but the square and the root, they get cancelled, giving you 13. Okay, now finally you need to obtain, you got AB, you got BC, you need to know what is CA squared. Okay, now CA squared, we start with the point or the coordinate or the vertex of A. The vertex of A is Z followed by a negative sign, and the vertex of C is going to be IZ. That has to be raised to the power 2. Now Z is given to be as 3 positive 2I followed by IZ. IZ you have found it to be as negative 2 positive 3I. That has to be raised to the power 2. So this is going to be equal to modulus 3 positive 2I negative negative positive 2 negative 3I raised to the power 2. And this is going to be rewritten as, now 3 added with 2 will give you 5, 2I negative 3I will give you negative I within the modulus, raise it to the power 2. When you apply the modulus, you will get root of 5 squared is 25, and this is going to give you 1 raised to the power 2, and that's going to be 26. So clearly you see that both AB squared and BC squared are same, and also AB squared added with BC squared gives you CA squared. So clearly you can conclude that it is an isosceles triangle. You can make the final conclusion. Since I don't have space, I can just simply write the final conclusion here. So I can state it here that since AB is equal to BC and AB squared plus BC squared is equal to CA squared, therefore it is an isosceles triangle, or